more stream yesterday and I decided to delete it because I just got stuck and I thought it wasn't interesting, so I decided to delete. I kind of regretted it as soon as I started streaming again yesterday because I was really tired. So, yeah. And I hate these kinds of problems, the one that I had to solve yesterday, and I ended up solving. But it reminds me a lot of arbitrage, where it's something like it feels like it should be easy, but it's very confusing. So it's really annoying to me, these kinds of things. But yeah, thankfully, I think I solved here, but there is the chance that there's something wrong. The results are kind of weird because my bat sizes are not what I expected them to be, the most frequent ones, but it might be because of the data. So I think that there's a decent chance that this is correct. So, but it's kind of weird because I was expecting another bat size as well, so I'm not 100% sure. But the thing that I had to do was convert the bats, because here I'm getting the value from the data and I want to convert the value into a percentage, but I have to convert the percentage in the way that Pio does it. And that's where the problem is. So if it's a bat, then I just got the percentage, which is the rule of 3, where you make the value of the pot equals to 100%, and then the value of the action equals to x, and then you multiply x by 100, and then new pot by x, and then you pass to the other side and divide. So this is pretty much this equation, and then I'm rounding. So I get only round values because I think Python only uses integers. So, and it shouldn't be that big of a deal to round because you're not gonna be able to be that precise anyway. So, and then here I'm using this stuff that I used on the other one, which is a delta, which reduces the variance of. So, for example, when I didn't have this, I solved everything, and then there was some bat size that was like 31%, and the other one was 31.33%, and so on. So it's like very redundant. So in order to prevent that from happening, I put this, which if there is a variance of 10% here, or I determine by whatever number I put here, I can put on the parameters as well if I want to. But I think I'm gonna leave it like this for now. Then it's gonna filter the bats that already exist, and it's not gonna put there. So it's only gonna put the value that is closer to the, or within the range that shows up the first time, within the range of 10%. And then previous bats. So this one is for the raises, and that's where I had to solve the equation. But I made another function for that, and I'm gonna explain this function now. And then the rest is the same thing. There is a difference though. If there is only one bat in the previous bat, that means it's the first raise, and that's where it got tricky and very confusing to do with the Pio stuff. And I imagine that is gonna be confusing as well now, because now I'm probably gonna continue building this part here. So I'm gonna have to figure out as well, like the whole. But I made another function that goes the other way. But I'm gonna have to figure out the other stuff and how to make the node ID as well. Translate the bats to the node ID, which is gonna be quite annoying as well. And those are the most annoying parts to me. I hate dealing with these kinds of problems where it's something like really easy, but you have to kind of just get out of the way, but it's really annoying to do. Load this thing here. Yeah, so if it's the first raise, then it's one thing, and if it's because I have to pass only the last bat, and if there was a raise before, then it means that that is a 3 bat, and then I have to pass both the last raise and the raise that happened before the last raise to calculate. And then doing like this, it allows me to only have one formula for both cases. And then the bats here is the same thing with the other one. I think I put a different number here though. I'm gonna make all of them 0.2, I think. Let me run here. And here I'm running and just printing the results that I get from this script that uses this thing here to update the bat space, to convert the bats based on, so that they're based on percentages. And then each time I have to, it returns the value of the bats. Oh, the other thing is that I'm making this new pot here so I don't change the original bat, because I realized that I have to call this twice on each street. One time for the hero and another time for the villain. So if I increase the original pot, then it increases twice as much, obviously. So I'm creating a different variable, and then I'm increasing the size of the pot after each action, so that the percentage is accurate. If the action is a bat, and if it is not, then it doesn't matter. So I just skip, and then I append to the previous bats the action, and return the new pot. And then I add the new pot to the starting pot one time, and use the starting pot again on the next iteration. And then this script returns the data structure, which this ended up being a lot longer than I thought it would be. Like, it's a lot of lines, but there's also some stuff here that's probably redundant, and I can get rid of it. So it returns this standard bats here, which is this data structure. And then, which is the thing that I'm printing here on this file. And now what I'm gonna do is think about how to translate this data structure into the tree format there. Or how to use these bats to pass through the tree to initialize a simulation. And yeah. So it has all the bats, and these are the most frequent bats. Oh, and it allows you to limit by the number. So if I put a higher number here, then this is only the 3 highest frequently. I'm not sure how to say that. The 3 most frequent bats. So whatever number I put here, if there are more bats, it's gonna show. So if I put 10 here, it's gonna show 10 bats on the flop here. If I limit to 3, these are the 3 most used ones. And this one seems to be correct. I think that's very accurate, but because it's a small sample size, I also think that, like, a lot of the times I use 100% pot as well, and then sometimes a little bit like an overbat or something like that. But that's definitely not often, so I think that based on the flop, it is correct. But the ones that it sounds like wrong to me is the river ones, where I'm not really sure that if it is correct or not. But I reviewed the calculations, and it seems everything that I did correct. I manually reviewed the formula with the tree in pile, navigating the tree in pile to see if the calculations were correct, and they were. So it's probably because of the data, but I'm not 100% sure, because I definitely use other sizes more, like 75% particularly. I think I would suspect that it would be here more. So maybe I'll increase the size. I did this before as well, increase the size of the frequency here, and then it showed different bats for the river. So let's put 12 here. And this is the raise. Let's put 13 here, or 10. And run again. Yeah, so now it shows more bats here. And it's just showing the other ones because these ones are not frequent. So it sorted by frequency. So the first one is the highest frequency, and the last one is the lowest frequency. So there's one 8 and 9 here, but which is kind of weird. So also I use 100% pot, I think, sometimes. So yeah, not sure about that, but once I have more data, then I think it's going to be better to figure out if it is correct or not. So the thing is, like, I hope it is correct, because I reviewed a bunch of different times and I couldn't find anything that it seemed wrong. So if it's not correct, it's going to take a long time to debug, because then it can be at any point of the system. So it can be on the part that I'm getting the data or whatever, on this other script or on the file there. So it's going to be hard to debug. but I'm gonna leave it like this for now. And then what I'm gonna do is on this script is add the ability to add my own bats if I want to, I think. And it's better to do it here, I think. So the way that I'm thinking about it is I separate the data bats in this file, in this script. And then from these data bats, I do some manipulation here if I want to. Like I can make a condition that if there is no bats on this that is close to an overbat, for example, then I replace one of the bats with the overbat. Like I replace the highest bat with the overbat, something like that. Like I can do all these kinds of things on this script here. Or I can do it after I initialize the tree, but then the problem is the size of the memory. So ideally you would limit. The other thing that is tricky here is that in position and out of position. I think from the standard bats doesn't make sense to separate the two because of the data, but it is obviously different. So like here is showing the most frequent actions that I take on the flop, and these are the bats I use, but this is most likely coming from in position because I almost never donk the flop. So that's the problem. This thing here doesn't take into account whether or not I'm in position or out of position. So if you use the same bats, then it's not like it is a problem when it comes to accuracy, but it is a problem when it comes to memory, because usually if the more bats you have on the flop increases the size of the tree exponentially. So in order to decrease the size of the tree, it's better to remove the flop sizes, because then it branches off until through all of decisions until the river. So if I'm on a situation where I'm out of position, then putting these 3 bat sizes here would be redundant and would increase the size of the tree. That's the problem. But then obviously what I thought about doing is just separating, like I said before. Just separate the thing where, because it's a lot easier to get the bats here if I don't separate based on in position and out of position. So this, like, I think is much better if I just get all of the bats based on the data here, and then separate into this file the logic for deciding how to optimize these bats so that it creates trees that I want. But I think initially I'm just gonna try to use the data for everything as much as possible, because it's more accurate, because there's the stuff that you think you are doing when you're playing, and then there's the stuff that you're actually doing. And obviously that's the discrepancy, and that's what you're trying to fix if you know what you're doing, obviously. If you study a lot and you understand the game. So, because the way that it works, like the reason why poker is challenging is because of the limbic system. The way that it works is that our brain is programmed to always avoid risk over uncertainty. Because of natural selection and evolution. So there's always this boundary between your comfort zone and our discomfort zone, let's say. And the way that people navigate that boundary is going to follow a Pareto distribution, where 80% are going to be risk averse and 20% are not going to be risk averse. And it forms this structure, which is the expansion of human consciousness throughout space-time. So what happens in poker is that whenever you're faced with a situation that there is uncertainty and you don't know what you're doing, you're going to default to your animal instincts. And then depending on your genetics, you are going to deviate from either side of the way. So you're either going to bluff too much, or you're going to not bluff too much, like be too passive or too aggressive. And the whole challenge of the game is learning the line better. And the way that this happens is your brain rationalizes. So you start having ideas of why you need to do certain things. But then that's obviously a rationalization based on your previous patterns of behaviors, because your identity is trying to survive, let's say, to maintain itself throughout space-time. So the whole thing about poker is, and the reason why I think that this is the good side of poker. Obviously, there's a bad side where most people just get addicted and lose money. But if you're playing seriously, the thing that it allows you to do is to reflect on your identity and to navigate this better, so you know in which ways you're lying to yourself and how your mind rationalizes like your behavior. But obviously it's more complicated than that, because risk is not linear as well. Risk is subjective because there's always an infinite amount of complexity over the risk that you take. And that's why it's the same thing with success, where there isn't a specific path, because the level of complexity is infinity, because your circumstances and the way that you are unique. So there isn't some set of instructions that you can follow or an algorithm that you can do to become successful. The only thing you can do is increase your odds, and that's a very analogous to poker. It's pretty much the exact same thing, the way that it works. So what you're doing is obviously trying to play a strategy that is going to increase your odds, but you have no control over the results because the level of complexity is infinity. And this is what the challenge is with poker, because if you have these decisions here, you can see that it's all based on frequencies, but all of these frequencies are always going to be relevant to the context of the situation. And that's why I believe that Nash equilibrium, the true Nash equilibrium of poker doesn't exist. Like, it's always a conversion towards a geometrical pattern of frequencies. So the ranges that represent the geometry of space-time, and the frequencies represent the fluctuation of the electromagnetic field in relationship to that context of space-time. And that's why you have this distribution here. So at every action that changes in relationship to the context, it changes the frequencies. And because of the frequencies, it's never a certain thing. So like, you can imagine that it's extremely hard to really know if you're checking 22% of the time or embedding 77% of the time, because you would have to keep track of everything that happened, and you would have to know exactly who you're playing against. So in practice, this is not going to happen. What's going to happen is you're going to get into a situation where there's uncertainty, you're going to deviate to your default behaviors. And then when you deviate to your default behaviors, you're going to start rationalizing, which is your body's going to make you have ideas that rationalize your current behavior, because it's based on your current identity. So yeah. So the process of becoming good is understanding, like, getting more self-awareness over the way that you rationalize, and at the same time understanding the mathematics behind it. So you have a good balance between the two. Because it's also impossible if you don't know the principles of the game. It's always also impossible to know if you're rationalizing or not, because you don't know where the line is, or you don't have a good idea of where the line is. So it doesn't matter if you know, for example, that you have the tendency of not bluffing too much or bluffing too much, if you don't know, if here you're using always the smaller size, for example, because then you might balance yourself in one level, but you're balancing yourself in relationship to the wrong mathematical equilibrium to the game based on the equities. And this is also a big challenge here. And I think that this is the greatest point of making this stuff this is why I think that this stuff that I'm building is going to be extremely good, because one of the hardest things is coming up with the pre-flop ranges for your opponents. Because if you build the simulation based on the ranges that you have, but they are very different from the ones that your opponents play, then there is going to be a very high chance that the equilibrium we find is very different than the ones that are happening in practice. And that's where the challenge is. So even if you train yourself with the simulations here a lot of time, then you're training yourself with the wrong equilibrium. And you might think in your mind that you're playing the correct strategy, but in reality, you're not, because it's the wrong equilibrium. And because of that, I think a lot of people don't understand, like, it is a science, but it's also an art. And that's the stuff that I was talking about before, where of the gradient of subjectivity to objectivity. It's a spectrum of density. So it's always relative, and there is no correct answer. And I think that's an exemplification of reality as well, or politics, or whatever you want to think about, because the only science that exists is relative. So science would be the relative Nash equilibrium you find by building the simulations here. But you are part of the experiment, and because of that, you place your embedded hidden assumptions over what's going on into the experiments, into the ranges, into the frequencies, and things like that. And because there's always an infinite amount of complexity, then you can never know if your experiments are an accurate representation of reality, because it has this element of self-fulfilling prophecy, where the calculations can only show you what you're putting on them. But what you're putting has always the assumptions, that's subconscious assumptions that you're making. So let me show the other. Yeah, so this function that I'm calling here, I pass the pot, pass the current action in the previous bat, if it is the first raise, and if it's a three bet or any other raises, then I pass the previous raise and the raise that happens 2 times before, to this function here, amount percentage. So, and this is the formula there. I remember that I had the formula before, but it was really confusing after to think about. But then I figured out, so the way that the formula was in this function here, and then I just passed the raise percentage to the other side and did the calculations. And then, so these formulas are the same, and this goes from the amount to the percent, and then this goes from the percent to the amount. So it takes the amount of which is the current raise, the amount that exists on the data, and then subtracts from the last raise, divides by the current pot plus last raise minus raise before last. And this is 0 if it is a bat. So if it is the first raise. So if it is the first raise, then the last raise is the bat, and the raise before last is 0. So it's current pot plus bat divided current raise minus minus the bat. So it would be, for example, let's say that they bat 120. You would be the current value, which is 300 here, for example, minus the 120, which is the bat, divided by the current pot, which is 280, which is 160, which is the previous pot. But the current pot is the one that takes the bat into account, so it's 280 plus the bat minus 0. So current pot plus the bat. So current pot 280 plus the bat, it should be 400. So it becomes 300 minus 120 divided by 400. And that's going to be 45%. I think, and I did this a bunch of times, and I think it's correct. Yeah, so now I think I should import this probably on the other one. The percent to amount. Yeah, now I have to figure this out. I think I'll erase this, just use this to populate there, the function. And I'm gonna do it like this now, but then after I figure everything out, I'm gonna encapsulate everything into a function, I think, again. And I'm gonna use this on another folder, probably, another file. So here I'm getting an arbitrary one first, then I'll think about how I'm gonna do it. I have to think about whether or not I'm gonna do the simulation first or get the simulation from Pile and investigate the simulation from Pile. So I try to reverse engineer the simulation so that I know how they do it, how they populate the tree. I think I also need to add this dot here to this thing so that the action is with the dot. And this is not going to be 0 if it's a 0 or fold. If it's a folder check. This is going to be either a C. I don't know what's the word for F. For fold. So yeah, from this data structure, I have the starting plots. So I have to think about which one I'm going to do first. I think it's better to try to do it with the single race plots because it takes more memory, so it's more likely that it will work on the 3-bat plots if it works on the single race plots because of the memory. And then here is going to be a starting plot. And then obviously I didn't multiply the bats by 100 because it's on percentages, so it doesn't matter. And the downside of doing things like this is that it requires me to run the bats here, but obviously what I can do as well is just cache this somewhere if I want, instead of creating the data and then use the cache version, and then I can put a parameter here that checks to see if there's a cache, and if there is, use the cache. If there's not, or maybe put some options as well to allow the person to decide whether they want to use the cached one or update the bats based on new data. But I think I'm gonna leave it like this for now, and I think about all this other stuff. Like the way that I'm thinking about it is I just get to the point where I have the simulations first. Like I have everything figured out, the system, and like kind of brute force approach, and then after that I think about like refactoring everything and making everything better. So now let me copy the arguments that it receives. The thing is, it's tough because I don't know if these are the correct arguments or all the arguments that I need. And also to traverse the tree is going to be difficult. To think about the cases and how to make, especially the calculations. That's the stuff that is very annoying. So flop, I think I can put any flop that I want here in the beginning. Let's put this rainbow flop and in position range. So big blind versus bottom. Oh, that's the other thing. I should put the other way around, like bottom versus big blind on one of them. I just realized that. And I'm using the 3-bat one, so it's single response. I think it's on like this. Yeah, single response. So who do I put? I think I'm gonna put myself in position. So bottom versus big blind. And then I leave it like this here. So I'm the in position one. So rearrange. Dylan's range. Starting pots. Active stack. Starting node ID. Yeah, I think this stuff here now, I can make it up, but then when I get from the data, it's gonna be... So this is actually always 0 here, I think. Then standard bats. I think this is always 0. So maybe I shouldn't pass as an argument, I should put 0 there. Because I thought... I don't know what I was thinking. I was thinking that it would depend on the flop. Probably. There's always gonna be 0. Because the first node is the root 0 node. I think I'm just gonna put like this here. And then I remove from the other one. Oh, remove the other one. Ah, there we go. So let me think. It's also, I'm thinking now whether or not I should separate the standard bats here and just leave the... just pass the bats themselves, but I think it's better to... Yeah, it depends. It's one of those things again where it depends on the way that I want to couple things or not, because then it will always require me to pass things on this format. But I think that's a good thing, because I think it makes it easier to think about in the same way that it is here, where this structure is going to be the parameters that I pass for this thing here. And then I'm just always going to use add all in, I think, for 67% of the initial effective stack. It doesn't change things too much, I think. It requires more memory, I think, if you put it on the flop. In general, it requires more memory, but on the flop is just a lot more, I think. So I'm trying to think as well if it makes more sense to do it like this, or to start doing with the bets that I have, or should try to load the tree from pile and then investigate the simulation, trying to use this thing here to investigate simulation. I think I'm gonna try to build with the data first, then I'll try to create one tree from the data. Yeah, I need to create the tree. Oh, let's see how I'm gonna do this. So I'm gonna have both the hero and standard bats. I'm gonna both have the hero bats, the raises, and the villains bats and raises and donks. Oh, that's the thing. I think I need to think about one street first, and then I'll think about the rest. It's still hard to do it, but And I put the data here. And so it will be like this, then be long actions here. Because I have to think about how to construct the possible paths that are gonna happen. I need the raises as well. Yeah, flop raises. So this is the data structure that I have there. I think the nodes, yeah, they accept the tree, the streets.
If you think about particles, and it turns out that things like positions and velocities are not very precisely defined.
Trying to think, well, what way makes more sense. I think I have to build the thing that constructs everything on one function. I'm trying to think if I can separate into the 3 different streets. The tricky part is going to be the turn as well. So for getting the possible cards, I think I just remove the flop cards from the... Maybe I can do another variable here called deck, and then pass all the cards, and then I just remove the ones that exist on the flop. But I'm not really sure how Pio does it, because there's also, obviously you're not gonna know the both players' cards, so okay, I think the turn has to be all possible cards, except the ones from the flop. It's kind of hard to... Maybe I should try navigate the tree with the... Like load the tree, then check to see if that's correct. Yeah, but here is only missing queen, jack, and 2. So it's all cards minus the ones that from the flop. That's how it works. 1, 2, 3, 4, 5, 13. So 13 times 4 is 52. It's 49 cards. So the possible turns, the reason why it gets tricky on the turn is because of the node here, and how I'm gonna construct the node, and the current range as well. The current range is the most difficult one, I think, because it has to be the range from the other actions. That's the most confusing. I guess it depends on the frequency of actions that each player takes, because that's the thing. I need the frequency of actions to create this that they take with each hand. The way that I'm thinking about it now was more from like getting the bats and then calculating the depth of the tree with the bats. Like I want to get all possible situations and not necessarily populate the tree. So maybe I should separate two different functions. One function I just create the whole tree based on the actions. Like navigate all possible situations based on the bats that I give there. And the other thing that is annoying me is the donk thing here as well. I didn't think about this. It might be necessary to just separate between out of position and in position on the other one, so I don't have the donks, because obviously, or I could just remove on this script here. Yeah, so I set based on the, I think I put the function here is in position or out of position. There's hero position and villain position, and then the name, and then it returns the object with the positions. So I can call this function, determine which one is the in position. The other thing that I just realized is it might be better to just, and because the way that I did here was because of the other file, the way that I was parsing before, but it might be better to put hero here. No, but I need the other name because hero is already here, so now it makes sense. So I just pass villain there as the second name, and then I use this to remove the donks from the layer that is in position from the standard bats. Yeah, make a condition, then based on the condition I open the streets. Because the in position player is not gonna have donks, so that makes sense. And it's gonna be yeah, later on, I think I will do the other stuff later on, because obviously the way that I'm gonna do it, that I was going to do is like get the position. Like as I create the files, I pass the positions. Maybe I can do it here, and that's better. So villain's position. But later on I'm gonna make an argument for this, I think, on the function. Or I'm gonna get it from the data. It depends, I think. Yeah, because like it gets too complicated if I think about everything at once. So it's better to just solve for one simple simulation. Then once I have the simulation, like the functions for, once I solve all the functions that I need for this class, then I think I can go back and see, which obviously is tricky because then it might change the way that I did the things here because of the thing that I'm gonna do eventually. But I think there's nothing I can do about this. Like it's better to just focus on this now, and then I'll think about it later. And then here would be villain's position, and here would be hero's position, and the other way, the one is the other way. So and then I pass here hero position, villain's position, and villain. And then I have to import this from there. Let's see if that's my position, their position, the name. So this is going to return an object that has EP and out of position. EP and out of position. Maybe I should separate it into a function, the one that receives the standard bats and then removes the donks. I think I could just delete the donks. I remember doing that on one of the functions. Delete donks. So hero actions. Yeah, hero actions has flop, turn, and river. And then they are a dictionary. So I can loop over them. The key is obviously the street, and the other ones is the donks, so just remove. I'm not really sure if this is the way it should delete. I could just print, I think. Oh, I forgot to put the positions. Yeah, nice. I think it worked. So now hero doesn't have the donks. So I think I should put like this, just so that it is the same there. Another thing is I should probably use the same kind of string for all of them. I just make sure. Yeah, I think it works. And turn, bats, raises, no donks. It's gonna give me the same thing because it's the same player. So now let me switch. Yeah, nice. So I think it's working. Okay, so now let me think. Yeah, so the question now is how to create an algorithm that is gonna give me... I think first I need to translate the percentages based on the starting point. And then the algorithm has to increase the starting points based on the action that it takes. The problem here is the ranges. I think that's the only thing. Because I need the current range for each node. But that depends on the actions that they take. Maybe I can initialize everything as like a normal distribution. Maybe not a normal distribution, but an even distribution. I'm not sure, 100% sure if it's the same or not. Because in the beginning I'm not gonna have any cards. I have the ranges, but then I don't have the frequency for the actions. And the thing is, I don't need the frequency for creating the simulation first, but I would need the frequencies to create the node lock. Well, if I'm doing with the data, then I'm gonna use the frequencies for the data to update. So maybe I just initialize everything as 0. I think I have the function there that does that. This create range here. I wonder if this is a good thing or not, where I'm thinking about inheriting the poker node on this one, but I'm not really sure if that makes sense. So I can use this function here. I think it doesn't make a lot of sense. Yeah, but this is a static method, so if I can leave outside and use on both. Yeah, I think I'm just gonna remove this from the function, from the class, and then just use the function. Yeah, I think I was using this before on the poker node, but I'm not. Oh, so maybe I would just pass this to the other function. Oh no, I'm using here. Yeah, so I think you should probably pass this to the other function. And then I just initialize everything with this create range, hand range. And then all of them are going to be 0 in the beginning. I think the paths of... I need to know how the add lines work on the script. Because that's I think the main thing that I'm trying to do here. In the first, create the tree and traverse the tree to get all the add line paths. Yeah, and then from that I can build the simulation. Then once I build the simulation, then I can update the values with the results that I get for the ranges. Yeah, so that's I think, so the first thing, I think I'm gonna write this down. So initialize every range with 0. Then get the add line paths by traversing the tree. Create simulation with the values in the tree. Use the results of simulation. Populate the tree ranges. So I'm gonna have to use the other function there that I have on the other file to convert from pile range to the tree range. Then once I populate the trees, then updates either save or updates. I can save before, right? So if I want to save, I can just save before. So decide if save or not. Updates ranges based on data and node lock. Solve again. Yeah, I think this is the feedback loop here. So saving the simulation would be like a cache, an optional cache. So that way, like, maybe I should check if I have the simulation or not. So I should have a method to check if I have simulation or not. And if I do have the simulation, then I skip the first step, which is this tree here. So let me think about this again. Because then I can start directly from the simulation that I have, just load the values and update the tree. So the other thing that I have to think is if the method to populate the tree is going to be the same as the one that I used to initialize with range 0. Because that's going to change the algorithm, I think. So maybe it should be the same function, but then I put a flag variable to indicate if it's cached or not, because then I'll have the ranges. So I can use the cache range if the cache exists, but if it doesn't, I will use the one created with this function here. And I think I'm gonna move this function to the other class and remove from here. And just pass as an argument. But then, let me think. And because this is the range for the strategy. So this is gonna come from the class itself, like it's gonna be the range of the class, so it doesn't matter here. I think this doesn't make sense. So this is node.range. Yeah, I'm tripping here. Because node.currentRange. Because the range on one level is the range on the other levels. Like, it's the same range split into actions, I think. It's kind of hard to explain. Yeah, but in the beginning, this is going to be the preflop range in the beginning, the first node. Then, but that's the thing, because it's not the same, because it has to be, there needs to be some calculation here that decides based on the frequency of actions. Like what is going to be, the strategy range is going to be a percentage of the current range, and that's the part that is difficult to think about. So let's say they take this, it's either call or bet, and they take 50-50, the actions. Then the current range, the range of the child is going to be the current range split by 50%. So it's just going to be the frequency times 50%. But that, it gets really complicated because it's a bunch of cards, a bunch of different frequencies, and a bunch of actions. And so the question is, should the node know all the possible actions? I think it should, probably. It should know the possible actions from the parent node. It doesn't it make sense, more sense if it's just one action, like one range for each node. But then how do you put the logic of the proportion of bats? I think maybe this has to be on the parent class, on the tree class. So the tree class determines the strategy of the ranges. So I remove this from here. And then each node only has the... I think that makes more sense. So I just remove these parts. And then remove that from there. And then I put this on the parent class. So the parent class contains the bats and contains the... updates the frequency of the bats for each node. And the nodes only hold the range for the specific path of the tree. So if it's a bat, then it has only the range for the bat, instead of having the full range. So what I'm talking about here is, instead of the node containing all of this information, it only contains this range here, which is the bat 120. Like one node contains this, another node contains this range, and the other node contains this one. And then the parent tree, the class tree, poker tree, has the frequencies of actions for each one, and constructs the ranges based on the parent one, because everything comes from the flop. So this is gonna have the parent range of all of the ranges, and it's gonna have the bats. So the updating mechanism should be on the poker tree. I think makes more sense, because initially it starts everything at 0, the frequency of each one. It can't be 0 though, because I'm gonna have to determine the subsequent ranges based on the frequency of the actions. So I think it starts everything with an equal amount for each one, and I think Pio does that as well. So this function here, I need to create a function that does this. So let me think. So I think I'm gonna pass this thing here. This it should be the initial range. And also I need to think about the order that I want to put them here. I think I'm gonna put this one first. And I think I'm gonna leave this one here for now. But maybe construct streets is not the best. I think I shouldn't. Yeah, I'm gonna think about this later. But it's not good to think about street. I think I have to create everything at once, I think. Because that's the only way to get the depth of the tree. Yeah, the only difference here would be the frequency here. So this calculation I'm gonna do based on instead of initializing for 0 here, I do based on the bats that has on the standard bats. So maybe I need to create a different function to manipulate the standard bats, so I just get the values that I want. Yeah, the thing is the branches as well, let me think. Yeah, so raises obviously always comes after the first bat. But this is something that I have to think about as well. Like the classification of everything. I think I need to use the same function that I used there before. To classify... I'm gonna have to use to convert to percentages, from percentage to the amount. But I should also use the other function that I did, or something, maybe create something similar on this one to determine the order of the bats. But I'm not really sure if it's necessary because I'm doing a tree, so... Like I can just make this distinction based on the type of the node that it is, I think. Because here I'm passing the... Maybe I shouldn't pass the streets. Or maybe I do. Because if I pass the street turn, then it means that it is a card. The node is a card. I think I can make it like that. And then the pot is just increasing the node, increasing the value based on the bat that I pass to each one. This auto position in position invested as well. I think it's necessary or not. It might not even be necessary to put this stuff here. The parents I can update based on the current nodes. Maybe should have a current node. I think this one has. Or is just south. But south, I think it doesn't work. Yeah, no, the parents go south. I think I'm thinking about too many things I need to clarify first, and then I'll decide which thing to do first. I think I'm gonna start off with this one. So the way that I'm gonna do it is change the value here to be an equal distribution depending on the actions of the flop of the bats. So everything starts off with the bats for the player that is in position. So maybe I should pass this information as well. Yeah, I think I should pass here. Because it is obviously a lot easier to figure out here, and then I pass who is in position and who is out of position. And then I make all the calculations based on that. So if the out of position player has bats, then I need to... The other thing is I need to take into consideration the checks and calls, which this data structure doesn't have. So after each bat, there should be one option for a call, along with the other options here, and each node should have... Yeah, but that's the problem. So if there is a bat before, then there's an option to call. And if there isn't a bat, then there's an option to check. But I think it's just an easy way to do this is just add a C to all the lines, because it doesn't matter. Yeah, I think that makes sense. So it adds outside, I think. Like after each action there is a C that can be taken. That represents either a check or a call. And then a fold as well that ends the tree. So I'm gonna do this recursively, so I'm thinking about too many things, but like the default case, I think one of the default cases is gonna be a fold, which is gonna return the function, because it means that the end of the tree has been reached. The other is if there are no more actions should be taken. So that's the other thing I have to think about. So it needs to be structured by levels. Like one player bet has to be associated with the other player raise, and this has to be determined based on the position of the players. So I think the first thing that I'm gonna do here, just like get this off of my mind, is put EP player on position player, and then it's just gonna be the names, I think. Player, CP player, and then here, so it's EP player first, and then out of position. And obviously I can decide here later. It should be actually depending on this thing here. It's better. Because I'm already getting which one is which before. So this makes a lot easier to think about here. So what I'm thinking about now is whether or not I should separate this into another, like make another function that uses this function. I think I also need to remove it from this one. So this just holds the current range, and then I do the calculation of the parent one. And do some. I usually do this a lot when I'm thinking, when I'm off stream. It's kind of addictive as well. I've been doing the other one a lot more, I think. Because I miss too much. And doing this a lot more. And this one feels more like the normal text. Let me go back to this thing here. Initialize a range with 0. So this should be different. Based on how many options first on has equal percentage. of hands for each node. But now that I'm thinking about this, it's probably better to figure out how Pio does it first. So use Pio to calculate. Because of all of these numbers here, because I'm gonna have to think about how to round them. Because I imagine like it's gonna get really precise really fast because it's all percentages. So like the first time it breaks down is gonna be 1. And the value of each hand is gonna be 1 for the parent, let's say. Actually, it's not gonna be 1 even in the first because it's the pre-flop range. So it's gonna be based on the pre-flop range, the values of the frequencies, and then that frequency is going to be split down between the amount of actions. So let's say I have 3 actions, so it's going to be 30. So let's say that for one hand is 76%, or let's say 75%. Then this hand is going to be split between the 3 different actions at 30%. So it's going to be 33% of 75%, and that's going to be the value of the hand on the child range. But then the other one is going to be a percentage of this amount, and then it's going to go on and on, and it's just going to get more and more precise. So you should know how Pio, because I assume that they don't have the exact numbers here. I don't know how to look into the frequency of each thing here. Here. So there's 4 different decimals of precision. And here is true, I think. But that's just the value. No, I think that is CV here, there. The other number. But then if I go here, it looks like it's always 4 decimals of precision. You can just round all of them. But the thing is, it must be, these values must be connected with the other ones. Obviously, there's no way that they're not. Because each, it starts everything like 1 here, and then if you bet, like you can see that it decreases, but so I assume these values are the cumulative percentage there that I'm talking about. Like the value that is showing there on the square, 47, 32, for example, A6. I think this is just the, like it's not the whole percentage, it's just from the percentage that this hand gets there, the amount that the action is taken, which is call. Yeah, I think that's what's going on. So the square there shows the percentages of actions from the hand, current hand, but they don't show the frequency, which is the way that I'm doing there now, I think. Because this frequency of the hand here is already embedded on the parent node, the decision of the parent node. Because the hand doesn't get here 100% of the time. So, and that's why on the vertical axis you can see that is not full to the top, but on the first part it is. So I think that's what's going on. And then the other value is just yeah, now it's 0%. just the amount for the hand on the specific thing. So I think it's not necessary to keep track of how frequently they keep track here, I think, of the lines, of the overall percentage, but I think for me it's just the percentage. I think the only thing that matters is the percentage of that each action is taken on each street. So maybe I don't even need yeah, let me think. I think that for this reason I should probably try to load the Pio tree first and update the class, the tree with the Pio information. I should investigate first. Yeah, I'm gonna do that. And then I'll think about the rest here. I think I have a folder that I initialize. Let me get this tree here that I have open. I think is the Stingray's spot. Oh, it has to be on the path there as well. So here what I was doing, I think I was showing the strategy and the children. So let me think about how I'm gonna do this. What's the best way? What I wanna do is traverse the thing and then let me get the function that I created to convert the file into ranges. I think it's this file. Yeah, convert range file. I'm not really sure which one it is. No, it's definitely this one. I should do the other way around as well. Yeah, that's what I'm trying to do. The other way around. So, let me think. I'm gonna put this on the utils folder here as well. And then I can think about, I'll think about the design after I get it working. And about everything. Like the whole project. But I'm probably gonna stick with the Bulldog parts for a long time. Until I get a bunch of data so I can see and optimize to do things that like are better for improving, I think. I think you can use the same function, you just pass the other format. Oh, no, I'm passing the dictionary. So it would be the same thing, but I just loop over and then I get the values instead of the keys. Let me think. So I have the sequence of lines, so the index is gonna be the value here. Yeah, I'm gonna do this now. So what I'm trying to do is load the simulation, get the strategies for each node, then convert the strategies from Pio format to the range format. And then once I have that, then I navigate and I make the calculations based on, like, to see the different ranges, to try to understand how they are constructed, the frequencies from one node to the other, so I can create a function on the other class to construct the tree. Range applicable parameter range. Okay, so now let me think. So I need to get the dictionary that contains ranges, that contains hands, and the frequency. So the index is gonna be the position. So I'm gonna loop over the values and the thing. So for index, value thing enumerates by a sequence. So the index is gonna be the card on the hand map. So I want to get the key that has the value. That's the thing. Oh, the thing is that this is sorted as well. I forgot about this. So I don't even need the... Yeah, but maybe it's better to get the value based on the value. I think it's better to get based on the value. So the Python sequence is going to be a sequence of floats, and this is the mapping. Like the value here is the index of the value on the sequence. So the first float is going to be representing this card here, this combo. So what I want to do is create the dictionary that has a combo and the value as the thing. So it's going to be a hand map, but with the difference that the value is going to be the value of the thing. So how do I do this? I need to get the key of the dictionary where that has the value. I think I'm gonna ask ChatGPT to say how to get the key of a dictionary that has a certain value, for example. I think soon I'll take a break probably. It's 1 hour and a half now. You can use a loop to iterate over all key value pairs in the dictionary and check if the value matches the given value. This is not very good, I think. Because it requires a nested for loop. Because I'm thinking about, I wonder if I can rely on the fact that this is sorted or not, or it's better to make based on the value. I think it's not even though that I think it would work. So for example, just looping over this and then updating based on this sequence here, like using the index to update. So I could do, for example, hands dict, this hand map, then the index, and this would be equal to value. So this would be the whole thing. And I think this works if it's like on these formats, because but then I don't know if I can rely on whether or not it's sorted. But this wouldn't work either, because it's getting the value, not the thing. Yeah, we need to get the index of the key. So I don't think this would work either. Is there any other way than using a nested for loop? I just make too many mistakes. Binary search. The question is, can I rely on the dictionary being sorted? I think I can, because it's hard coded up there, but then the question is like, what if I want to remove this from here and then pass as an argument, for example, for whatever reason? I think I'm just gonna do it as if it is always gonna be sorted. I just use the stuff that Pyro gave. I'm using the binary search. Problem is I'm doing this for each item. Oh. And maybe I can go back and do it the other way around. Where the key represents the index. I don't remember really well how I did this. I'm thinking whether or not it makes sense to figure out or remember how I did the mapping and then do it the other way. So I have the keys as index and the values as the cards. Or I could just loop over this and then update the values. Because I know that will be sorted. Yeah, initialize a count here and then use the count. So it splits. Yeah, that works. Because I have the thing. Yeah, that works. I think this works. So let me print here. I think this is better than the answer Pyle gave. So let me... I'm using the same key there, and then I'm just getting the value based on the index, which is the value here, on the here. I think works. Yeah, but now I need a string, so I'm gonna get it from the file there. in zone 3 building. Yeah, I think it is correct. Probably. Maybe that I can test here. So let me think. I guess I can just paste here. Yeah, paste like this. It's gonna take some time to copy everything. Okay, nice. Because it has to be not a dictionary, I think. Let me see here. Yeah, it's just the string. But I think if I save this, then it will work. It doesn't work. Yeah, I think it works. I'm not gonna spend a lot of time on this. But it works based on the values here. I can already see there. It's not worth. As you can see here, that is this value, and here is exactly the same. And is mapped based on the index, so there's a very... Yeah, I think I'm confident that this is the right thing there. So this works to map the other way around. And convert Pyro to range. I'm gonna run this again to see if it works. It takes some time. But maybe I shouldn't. Should just remove this line, I think. Show the metadata. Yeah, I'm gonna remove this line. So this, if I remember correctly, is gonna show the tree. It's gonna show what decisions exist after this node here, which is this nodes here. So it's just gonna show bat 120 and then bat 48 and check on the node ID, and then it shows the strategy for each one, I think, based on this line here. And is for the node ID that I provided, which now is the root. So what I need to do is like get these outputs and then populate the tree with these outputs, I think. So what I should do is probably import the range tree there and then manually put these values for each one. For the players, and then try to use the values that I'm getting from Pio to populate them, populate the tree. And then once I have the tree, then I'll go back to the stuff that I was writing here of these steps, because I want to be able to initialize everything without having the solution in Pio. Then use the tree to create the solution, and then from the solution either save or update with the other values. So the biggest challenge I think is figuring out the percentages here, like the relationship between percentages in the ranges, and then I think everything else I can see a path to do it. Just traversing the tree and adding child nodes, and I think it's gonna take some time because I'm probably gonna make mistakes, a lot of mistakes adding, because I'm terrible with recursion. But it shouldn't be impossible, I think. And once that part is done, I think this is the hardest part, and then everything else should be easy. Probably, hopefully. Because then it's just a matter of updating the tree with the data you get. So I can add an option to either update from the cached simulations, like I said before, or update from scratch. Create the tree just with the data without creating the simulation first, and then solve from that position, from that point with the data. And the other tricky part is the whole thing about the hero and villain, like deciding which one to do it, like which one to node lock stuff with. And this is also gonna be challenging, like determining the, like giving options not to only to node lock only certain parts of the tree. And but I can also see a path to do that. Like it shouldn't be that hard, I think. And then also giving the option to change the bats as well, the ranges. I think I'm gonna stop here today, and I'm gonna work on this off stream. Oh, now it goes. So yeah, this is some problem that I have with this thing as well. I had sometimes, which is because of the I'm not really sure how to solve this. It's because of the execution there. Like this wait for solver doesn't work really well, but I can't think about anything because I try to use the connection.wait, because this class uses a sub process from Python. And then this subprocess, the pop open has the option to, there's a method that is wait, but then the problem is that it waits forever unless you pass an amount of time. But then the problem is figuring out the amount of time, because obviously it's going to depend on what thing you're doing. So if you put too much, then it's going to take just a longest time for something that might not took that long if you didn't put the wait. But if you put not high enough, then it breaks down. And here it is calling this wait with 1 when you call the exit method, and the wait for solver should wait until the solver is finished with the whatever it has to do. But the problem is that it doesn't finish well, so that it calls this method before the solver has finished whatever it needs to do. And that's the issue. And then it gives me this warning here. So I thought about either changing the sub-process that I use here, but then it changes everything else. Because if you use the one that you can run without... you can run and it's gonna wait. It's a different sub-process, but then you can't really pass the right lines here, I think, on the commands. Like the only way to pass the lines is if you determine like when to close the thing. And here it's saying timeout after 1 second because of this call here. because it killed the solver too early. So the only thing that I found, I think, was to use more wait for solver lines here. And I think one time this worked, but then it depends, I think. I'm gonna remove these comments as well, because I'm probably gonna do different things. But I'm gonna try again with the wait for solver. At 2 times there. So the show children method shows these things here, I think. Maybe I shouldn't print everything else. I think the other stuff is the metadata, so it's probably not gonna print now. Let's see. Yeah, solver connected successfully, then all the metadata. Then the children method is this one, I think. So the first child is the call, which is this, or check, this node here. Which is also something that is kind of tricky to understand, because I don't know like if the value of this tree is the turn or the action itself. So that's kind of tricky. Oh, maybe it's talking about this node here. Yeah, this node. So the child of the root is this node here, which has the 3 children as well. So it shows here 3 children. So I think what I can do here is just use this show children methods, and then based on the lines, I'll do... Yeah, I'm gonna do a different function than the print lines here. And then based on the line, I navigate, and then I navigate and populate the range tree that I have there with the values. But I think I'm gonna stop here to eat things and take a break. So I'm gonna probably... I'm not really sure if I'm gonna come back. Maybe I'll just do the rest of this, or just work on this off stream and then come back tomorrow. But I might come back in some hours to continue to do this, because I think this part is the most interesting one probably with the tree, and the most challenging one as well. But I might do it off stream. So if I don't come back, I'm probably gonna come back tomorrow to continue to do this, or I might come back today in a few hours to continue to do it.